All right, so some things you need to make sure you know for your test. This is pretty much all of Unit 6. I'm not leaving anything out. I'm just making a big long list, okay? So we got kinetic molecular theory. We got states of matter. You need to know what makes a solid, a liquid, a gas. You need to know what makes up a solid, liquid, or gas in terms of their molecules and how they are moving, their kinetic energy and stuff. And that's what kinetic molecular theory talks about. So know all of those parts. States of matter, phase diagrams. You will have phase diagram on the test. Heating curve. You will probably have questions about a heating curve. Gas laws. Gas stoichiometry. What else is there? That's kind of the main points. Seems like I had some more on there though. So now, as far as gas laws, they do not memorize any gas laws at all. Period. None. Do not spend your time memorizing them. They are on the reference sheet. All the ones you need are on the reference sheet. What you need to spend your time doing is understanding the relationship between pressure and volume and temperature and number of moles by looking at the equation. You don't have to memorize it, just look at it and know. Yes, Kendra? No. Molar mass is, what do you mean by molar mass equation? Oh, the DERP equation? Yes. Now that one you might need to know. That one is not on the reference sheet. Okay. But be able to look at these. And if two things are multiplied together, that means it's an indirect relationship. If two things are divided, it means it's a direct relationship. As far as ideal gas law, if they're on the same side of the equation, the equal sign, that's an indirect relationship. If they're on opposite sides of the equal sign, that's a direct relationship. Okay. As far as Dalton's law goes, it's on there, so you need to pay attention to things, words like collected over water. That means you're probably going to use this and subtract out the pressure of the water, which you did when we did our lab. Okay. The rest is just working out problems and being able to identify the parts of a phase diagram and a heating curve. And that's pretty much it. Oh, yeah, ideal gas. You need to know what an ideal gas is. Yeah. You need to know about your, like you said, I said, your three states of matter. When we get to solids in your notes, we talked about crystalline solids and amorphous solids. Make sure you know the difference between those two. Know what freezing is, what melting is, all those types of things. And then know how to work your gas laws. Just what we've been doing. And then the stoichiometry part, the gas stoichiometry part. And that's the part where you're going to have to give it grams and have to change grams to moles, and then go on from there and maybe change moles to volume or pressure, or change fine pressure or something like that. Okay. All right. So the rest of the time, take out your gas law worksheets and we'll go over any questions you had on those. Hopefully you got at least one completely done yesterday. Should have. Because I know that we did half of two of them. All right, so find those, and we'll just go over any questions you have over those.
So, are we gonna have a retest of this like we did?
I don't know. See.
How bad we do.
We'll see.
On the second gas law sheet, you are number 9.
Yes.
It's kind of just an insurance thing.
Well, let's not think about the insurance right now. Let's just prepare. Preparation is better insurance than insurance. Just prepare. Just prepare. All right, so gas laws number 2, gas laws worksheet number 2. We're going to look at number 9. Okay. What is the molar mass of 0.625 grams that has a volume of 165 milliliters at STP? All right, so we have 165 milliliters. We're at standard temperature and pressure. And we have 0.625 grams. And we want to know molar mass, the mass in 1 mole. So, what are we going to use? Meow. Derp. Derp. Molar mass equals density times R T over P. How are we going to find density? Density is what? Mass divided by volume. So 0.625 grams divided by 0.165 liters. 0.821 liter atmosphere mole Kelvin. And then my temperature is 273 Kelvin because I'm at standard temperature. And standard pressure is 1 atmosphere. Go away. So I'm left with grams over moles, which is molar mass. So that's going to be. So I'm going to do that division first, 0.625 divided by 0.165. And then I'm going to multiply that by 0.0821. Then I'm going to multiply that by 273. And then I'm going to divide that by 1. So it is 84.89 or 85 grams per mole. I don't know what the key says. It might say 84.9. It might say 85. I don't know. Either one's fine.
I kind of forgot that it was.
Yep. Okay. Next.
On this first worksheet, did you ever sit?
Yep. All right. All right. I have an unknown volume of gas at a pressure of 0.5 atmospheres and a temperature of 325 K. If I raise the pressure to 135 kP, decrease the temperature to 320, and measure the final volume to be 48 liters, what was the initial volume? So I need to make a list of what I have. So I have a initial pressure, P1 is 0.5 atmospheres. T1, initial temperature is 325. V1, I don't know. They didn't tell me. But then they said they changed the temperature, so that's T2, to 320. And they changed the pressure to 135 kilopascals. And the volume changed to 48 liters. So what law am I going to use? Combine.
Change kilopascals to
Exactly.
atmosphere or atmosphere to kilopascal.
So I have this law is the one I'm going to use. But I have to have the same units for my pressure. So I'm going to change kilopascals to atmospheres. There's 101.3, and this is on your reference sheet. You don't have to have it memorized, in 1 atmosphere. All right, so 0.5 atmospheres times V1 over 325 equals, whatever that is, 135 divided by 101.3. 1.33 atmospheres times 48 liters divided by 320 K. Cross multiply and divide. So I'm going to take 1.33 times 48 times 325. And that gives me 20789.73. 320 times 0.5, 160. V. Divide both sides by 160. So this is liter atmosphere kelvins, and that is atmosphere kelvins. So the only thing still standing is the liters. 2078973 divided by 160. That doesn't seem right. I missed a decimal somewhere.
Which worksheet is this
Whew. The first one,
on?
1.33 times 48 times 325. Not only did I miss a decimal, I forgot to clear out my calculator. My number is completely wrong. 20748. There we go. Now I divide that by 160. There we go. 129.7 liters. Yep. And that's my answer. Okay. So make sure you're changing Celsius to Kelvin. Make sure all of your units are the same unit. They have to be converted to the same unit. Okay? Next.
Is the kinetic molecular theory in the notes?
Mm-hmm.
So,
Yep.
do we need to pass these down?
What is that?
The bell ring.
Bell ringers, yeah. Bell ringers go to the end of the table. Yes, ma'am. Okay. Gas stoichiometry, number 2. So, a sample of methane gas has a volume of 2.8 liters at 25 degrees Celsius, 1.6 atmospheres, mixed with a sample of oxygen. The mixture is ignited to form carbon dioxide and water. Calculate the volume of CO2 formed at a pressure of 2 atmospheres and a temperature of 120 Celsius, 25 Celsius. So here is our equation. CH4 plus 2O2 goes to CO2 plus 2H2O. And, all right, so we have 2.8 liters of methane, 1.65 atmospheres, and 298 Kelvin. And then I'm looking for the volume of CO2 when my pressure is 2.5 atmospheres and my temperature is 125 plus 273 is what? 398. Okay, so what am I going to do? I have CH4, but I need CO2.
Same.
Yeah, it's the same equation. Different starting conditions. So what am I going to do? If I have liters of CH4 and pressure and temperature for CH4, how am I going to turn that into liters of CO2? What do I need to do? Anybody? Catherine?
So I would start first with CH4, and I would find the moles using actual gas law, and then convert those moles into mole ratio, outside, and then from there, move into
Anytime. So again, you're looking for where do I start? If you are given a reactant and asked something about products, you have to have moles. You cannot go from one compound to another compound without moles. So you need to be, if you're looking at that and you say, all right, this is methane, I'm looking for CO2, I have to find the moles of methane somehow. Can't do anything else till then. So if I have pressure, I have temperature, and I have volume, it's pretty easy to find moles. Plug it in the ideal gas law. So my number of moles is going to be equal to my pressure, 1.65 atmospheres, times my volume, 2.8 liters, divided by my gas constant, times my temperature. I just rearranged that equation before I plugged in. That's all I did. 1.65 times 2.8 is 4.62. And then 0.0821 times 298 is 24.465. So 4.62 divided by 24.465. 0.1888. That's moles of CH4. So, what am I going to do now?
Use the mole ratio to find how many moles of carbon dioxide.
I'm going to take my moles of CH4 and turn it into moles of carbon dioxide. What is my mole ratio for that? 1 to 1. So that luckily comes out to be the same number. So what am I going to do now? I have moles of CO2, but I'm looking for volume of CO2. And I have pressure and I have temperature. So what am I going to do? Plug it back into that ideal gas law again, using my new conditions, and find volume. So wait a minute. So I'm going to go ahead and let's do it this way. Never mind. That's too confusing. So my volume is going to be equal to 0.1888 times 0.0821 times 398 divided by 2.5 times 0.21 times 398 divided by 2.5. 2.46 liters of CO2. Okay. So whenever you have two different compounds, you need to be thinking, I've got to change into moles. Whatever they gave you, I got to change it to moles. Because that's the only way I can change between compounds is the mole ratio. Okay? Yes?
Can you do number 17 on the gas law practice?
Yes. That's a fun one. Okay. All right. So they give you this equation. CS2 plus 3O2 goes to form CO2 and 2SO2. And all they tell you is that you have 4.25 liters of O2. Oops, I put it under the wrong thing. And then they want you to find the liters of this and the liters of this. But they don't tell you anything else. They don't tell you pressure. They don't tell you temperature. They don't tell you nothing else. They just say it stays the same. Okay? So, if we look at this, pressure's the same. If we're comparing these two things, we're going to compare, let's say we compare the ideal gas law for the O2 to the ideal gas law for the CO2. Okay, if we make a ratio of those two things, what things are going to cancel out in our ratio? So what's the same in both situations? The pressure is the same. What else? The temperature is the same. R is a constant, right? So it's the same. Pressure, RT. So what are we actually comparing? The volumes and the moles. So if we said the volume of O2 is equal to the moles of O2, when we compare that, or we make a ratio of the volume of CO2 to the moles of CO2, what do we call those things? Two ratios. A proportion. So we're going to make a proportion. So 4.25 liters volume of CO2, I don't know what that is. I do know that I have how many moles, according to my equation? How many moles of CO2 of O2 do I have? 3. How many moles of CO2 do I have? 1. So how do I solve for V? It's a proportion. How do I solve for the cross multiply and divide? So my volume of CO2 is just going to be equal to 4.25 liters divided by the 3 moles. Yeah. And then I'm going to do the same thing for water, or for SO2. Set up a proportion like that. Okay.
Well, there'd be a question like how this has.
It's possible. It's just making a ratio. That's all it is. Because they told you that the pressure and temperature is the same, you're just going to make that ratio. You can't use dimensional analysis the way we have been because this is not standard temperature and pressure. So we can't just convert liters to moles using STP because we're not at STP, which is why I decided to make a proportion. I can use the mole ratio though because I use 3 times as much O2 as I do CO2. Okay, so I can use that mole ratio and relate it to volume. Because according to this, volume and number of moles are what?
Oh,
They're not the same, but they're what kind of relationship?
direct.
A direct relationship. Yeah. They're a direct relationship. So if I change the number of moles of CO2, which I did, I dropped the number of moles of CO2, went from 3 down to 1. So my volume of CO2 should be lower than 4.65. So I can use that. Any other questions? So make sure you have your notes done. Study your notes. You should already have been studying, but study your notes. Use the practice problems. You have the answer keys for those. So you can use the practice problems to make sure you know how to do the problems. And that's pretty much it. You do need to finish within the class period. So make sure you come in ready to get started when the bell rings. Okay.